Getting started making a top-down game doesn't have to be difficult. In this video, you'll see how you can make a top-down character move in Godot in under 10 lines of code. You'll then learn to make it face where it's moving. To move objects in a game, we use physics bodies. There are two main types, rigid and kinematic bodies. Rigid bodies are great for realistic physics. They're easy to set up but hard to master. Kinematic bodies, on the other hand, give you full control over your character's movement and are perfect for Zelda-like games. In a new scene, we create a kinematic body 2D node with a collision shape 2D and a sprite as children. You can use either a square or a circle collision shape. The square will give you more precise collisions, but the circle will make the character naturally slide against obstacles. After adding a script to the kinematic body, we first export a speed variable so we can alter its value in the inspector. As our character needs to collide with other physics bodies, we write the movement code in the physics process function. Every frame, we get the player's movement input as a vector too. Input getActionStrength returns a value from 0 to 1. With this function, if you press the corresponding key on the keyboard, you get a value of 1. With a joystick, you'll get values between 0 and 1, depending on how hard the player's pushing the stick in the given direction. We convert the input to a move direction by normalizing the input vector. Normalizing a vector ensures it has a length of 1. Without that, the character will move 40% faster when going diagonally, as seen in games like Forager. In most top-down games though, we don't want that. Now comes the movement. Godot's kinematic bodies come with a function called move and slide that does a lot for us. You give it a velocity and it handles the character's motion and collisions. To calculate the character's velocity, we multiply the move direction by its speed and call the move and slide function. And with only those few lines of code, our character moves. It even slides smoothly against obstacles. To change the character when moving in different directions, we add a script to the sprite. We use a dictionary to map each input direction to different sprites. Dictionaries map unique keys to values. We use a vector 2 for each key, which represents a direction. And for each direction, we preload a texture to put on the sprite. Preloading is smart, so if we load the same texture twice, it loads it only once at the start of the game. In this script, we need to keep track of the character's look direction to know when to change the sprite. Every frame, we calculate the player's raw input direction to detect movement. The sprite doesn't interact with physics, so we use the process function this time. As we've seen, using a joystick returns a value between 0 and 1, which might give us an input vector that doesn't match any of the keys in the dictionary, resulting in an error. We get around this by instead detecting whether the direction is pressed or not, and convert the boolean into a float. We check if the input length is greater than 0, and if the input is different from the look direction. If the input is 0, the character isn't moving, so we don't need to change anything. Same if the look direction didn't change. If the two conditions are met, we switch the sprite to the correct one using the player input as the key in our dictionary, and we store the look direction. We only have textures that face right. To have the character look to the left, we flip the sprite horizontally. Finally, we move the sprite up and down along a sine wave to simulate a hover by grabbing how much time has passed in milliseconds. And with just that, we have a flying character that moves, turns, and smoothly slides against obstacles. Separating the sprite code from the character movement like we did makes it easier to add more features to either. It can help keep scripts short and easy to read as your game gets bigger, which is why we showed you that approach. You can see how Godot makes character movement easy. It really does a lot to keep things simple for you. Still, learning to make games and code can be a daunting and difficult task. Most courses out there are too superficial. They don't explain why they do things this way or that way. Right now we're on Kickstarter to fund Learn to Code from Zero with Godot. We've been working for months already to make the course we wish we had back when we got started. You can back the campaign to make this a reality and get the course at a lower price, but you only have until October 31st. So check the campaign now on Kickstarter.